Hello, everybody. So, into week 3, we are over a quarter of the way done with this course. 8-week courses go quick. 8 weeks goes by quick. Got a few things to look at today. Well, we did 2 weeks on Pygame, scripting our games. But we've got a lot to look at. So for the next 2 weeks, we're going to be looking at one where we can do it all in the interface. We're dragging our mouse around and clicking the mouse buttons. So lounge back on a couch, dragging the mouse around in a comfortable position, that sort of thing. And then the last 4 weeks, we'll look at one that mixes them really well. Actually, most of them that have an interface mix it. We're just only going to look at the interface. They do have their own scripting language, which is modified JavaScript. So anybody knows JavaScript, you 99% know the custom language for the next engine we're going to look at already. Really, it's a custom JavaScript library is what their language is. But we'll get there because we're going to take a quick first look at it. And then the big thing for today is getting started looking at some graphics. The next game engine we're going to look at is very intuitive. It's been around for many decades. A lot longer than a lot of y'all have been alive. So it's been gotten well refined over the years, and most people find it very intuitive, easy to work with. So that's why I wanted to take a quick look at it first. And before you get into the tutorials for it, just randomly click around, see what you can figure out on your own before you start following instructions. Because I think you'll find that it's very, very easy to work with. I was in that situation when I took the game development course. When was that? 2011 or 12, 10 or 11 years ago. When I was a student at Ivy Tech and took the game development course. We used Game Maker for the course, and I installed it. And before having any instructions on it, just from clicking around, I basically made a full little role-playing game just because it's very, very intuitive. So click around and try things, see what you can figure out before looking at it. So I have a short list here. I'm going to formally write the list down at some point later in the semester. First couple items, the first thing you always want to look for is make sure you look for transformation data first. Transformation. I'll write an S. Transformations are kind of the big one for game development. There's several other things on this list. We've seen them in 2 different engines. I was going to refer to all of them. But most of your graphics are entirely based off transformation. And some background things as well, because we leave some things transparent in our game. But transformation, that includes location, rotation, and scale. I have a list of things. I'm going to, like my recommendations, the first, how many of them? 1, 2, 3, 4, 5, 6, 7 things. So the first 7 things you want to learn when you look at it. And this is always going to be number 1. We'll get to the rest of the list in a couple weeks, because I want to look at it in 2 different settings and then read down that list so that hopefully you'll have seen those same things in more than one setting. And that's another thing. We talked about the logic, did our first lesson talking about game logic and Pygame. And when we talk about game logic, it's not going to change when we go to a different engine. So what you'll want to be looking for, since we are in a time constraints here, pay attention to what they have in common. Transformation data. That's our basic thing. You're going to be able to handle the same transformations in any game engine you work with. So try to focus on what they have in common instead of looking at the differences. So obviously there's going to be a lot of differences and a lot of commonalities, and the commonalities are what we would consider general game development logic. So as we move on to our second engine, and then in a couple weeks when we move on to Unity, make sure you're trying to pay attention to what they have in common, not what's different between them. You don't want to try to sit down and memorize every single thing. Plus, it's software. So like all programming, even to the languages themselves, it's software. It gets updated. Things change. You're going to end up looking stuff up no matter what. People often wonder when they should stop looking stuff up, and really never, because it's software. It's going to update. We just finished looking at a Python section, and it just so happened our first day of class was the day the newest version of Python came out. And there is something in there which is definitely in the new in 3.11, which is definitely going to go into every game engine working made in Pygame or Python very soon. So we'll see it in Pygame, Panda 3D, and there's a long list, obviously, but they extended the match case, which came out in 3.10, and it has no base graphs now, which is going to make a big difference in game development, but that's beyond the scope of what we're talking about in this class. So pretty much every game engine written in Python, we can guarantee is going to be updated very soon because of a huge improvement in the language that is directly applicable to games, directly applicable to what we are transforming. And every one of our games has that as our primary data. That's the right. That's why we tie the background data and the graphics together. So really, that's our pipeline. Numbers running through the CPU and where that picture is displayed on the screen. So a very important thing. And the big thing today is looking at some graphic stuff. So we looked at Inkscape a little. So we might use that same image again, but when we looked at animations very quickly last week, we drew several different frames of the animation. Simple animation like that, the test case and all that, it's not too bad to do, but it's a lot easier if we only have to draw the picture once and the computer animates it for us. So we'll look at how to do that in 2D. 3D, it applies the same way, so we do have to do, that is something we have to use vector graphics for. That's why I picked Inkscape, that's 2D vector graphics. And we'll take our first look at 3D graphics in Blender. When I pull up this video, I'll start with that. Let's see. Oh, I think I do have to share my audio. I'm gonna share my screen this time because it's going to be from a video. So we're going to look at Blender for 3D graphics. This is a very popular software, immensely popular, can do Hollywood quality CGI quickly on any computer. I always use the cheapest computers off Walmart, and I've been using Blender for decades. There's a little advantage in there. It doesn't usually show up in a classroom because it's time consuming for software development, but it's a very, very useful trick for software developers to know. So I'll talk about that at one point. Because when we look at the software, it will do very large, impressive things that you would be surprised will be running on the cheapest laptop they make at Walmart that I'm doing here during a Zoom call. It's the way the software is created gives us a big advantage, which is good for software development in general. So I'm going to look at a particular video here. Bob Ross and Blender. Let's see if this gets it. Oh, yep.
Millions find a low-cost health plan at healthcare.gov.
Can you all hear that on the thing?
Yes.
I don't think I need to share my screen. It will pick back up. No, actually, yeah, I should do that.
So they can.
I'll mute the commercial. Sorry, it's YouTube. At least there's only 2 ads this time. Nope, that's not the video I wanted. Okay, yeah, this guy. So first off, look at the length of time on this tutorial. So this is a how-to tutorial. 18 minutes long, which means he has to take time to explain what he's doing along the way, not just rapidly go through the steps. 20 minutes to explain it. And in 20 minutes, I'll make that 3D world. So we do really high quality CGI stuff very, very easily, very, very quickly. Obviously, we're not going to do that on day one of the class, but I come across that video about a year ago and thought that made a great example just for people who aren't familiar with Blender. That's 16 minutes into a tutorial. So he's explaining how to do it and periodically undoing and redoing to go over the process. It has a scenery that looks like that, a world that looks like that in a few minutes. So very, very powerful graphic software. Immensely popular. It's open source, so there's a huge worldwide community working on it. You can look into the details of Blender later, but it will be compatible with pretty much any game engine you know. And technically there is a game engine. They used to have a game engine included, but they pulled the game engine out to focus more on graphics because their stuff it's so big, even though it's an open source software, every Unity and Unreal and everybody else automatically thinks of Blender when they make their game engine. So Blender was like, okay, we're compatible with every game engine, so we're going to go with adjust the quality level and put all their focus there. But they didn't delete their own game engine when they did that, so it still exists. You just have to go to GitHub and download the code. It's written entirely in Python, so obviously the game engine is written entirely in Python. But that's not really what we're looking at. So to start here, before we get into the graphic stuff, our next step is Game Maker. And like I was saying earlier, you want to, you're going to need to get this installed pretty quick. And try clicking around on things before you start watching the tutorials. Oh, and all the tutorials on the website are built right in here. So you don't even have to go download stuff from the website to do that. You can get to the tutorials right here. Just pick whichever one you want. The intermediate ones are a little more time consuming. There's extra steps to show a bunch of tools and stuff. So they will take a little bit longer than the beginner ones. I would recommend looking at the beginner ones just to see that the basic structure. And dungeon tutorials, sort of like an overhead map walking around the world. The fire jump is an infinite platformer upward. Little Town is a village where you walk around and interact with NPCs. Just pick either one of those or a regular platformer template. And they have more tutorials available. I think there's at least 2 more on their website right now, so you check the website. But we need to create it as a project. A game is not just a single file, so we need a new project to keep all the files straight. So create a new project. It looks like there's an asteroids tutorial right here. A bunch of tutorials. We'll just do a blank project. I'll call it class 1. And sure, that looks like a good place to keep it.
And that's where, because I was able to log in, but after that, it start up a new project.
It wouldn't do this, get to this right here.
Yeah. Like it'll say I'm signed in, get to blank project, and that's it.
Okay, I might have to look at that later. You should be seeing this when you log in. Jared's having trouble with it, but maybe else having trouble, let me know and we'll look at it. I'll try to figure out what's going wrong and check into solutions. See over in the left-hand side is an inspector. That's something we'll see in most graphical user interfaces related to game engines. And like the name implies, it allows us to inspect what is happening on every one of our games. In the middle is a big workspace area. And over on the right is a bunch of assets. get the Zoom stuff out of the way. And if I go here to where create the project, see there's a folder that already has a bunch of stuff in it. So everything should be organized. And as we look through this list, a few things should catch your eye. Like the word objects. For my little zoom in. I'll circle them all I talk about. Let me get those out of the way. Got my little pen. Objects sounds like it would be important. We're probably gonna want some game objects. Rooms. I'm gonna have to think a little bit about that, but probably not too long. That's what they call scenes. So there's your scenes, your levels, all of that stuff. Sequences, shaders, sounds, sprites. Well, sprites are the images. So we'll create an image and then attach that to an object, and the object will have the logic. And we did that in Game Maker at least once in our short amount of time. We had the Python object, which we actually used in our game, and then it had a lot of different values like sprites and sound effects and all sorts of different things we have. Timelines, tile sets, a lot of useful tools there. But start clicking around to see what you can come up with. A good first thing is usually to right click, right? I think everybody's well aware of that. If you're not sure where to start at, try right clicking, see what you get. And see something says assets, windows. So we know we need game assets. So first thing we probably need is a sprite. So we'll create a new sprite. Oh, let me zoom here. Oh, did somebody just disappear? Perhaps. I'll need to watch that and see if they come back in. So in this big workflow area, looks like we can put lots of stuff in there. Oh. The mouse wheel obviously moves that area up and down. And if you click your mouse wheel, you can move left and right. So, or kind of pan the stuff around, holding down the mouse button and moving around. So a real mouse is very, very beneficial. All the stuff can be done with the touchpad on your laptop and using like alt click and I think control alt click, and those handle the scroll wheel and stuff. But it's a lot easier if you can find a regular mouse somewhere. For those in here, if you don't have a regular mouse with your laptop, you can probably unplug it from the computer next to you, or the closet's open. Yeah, there's a box right there in the closet back room if you need a mouse to plug with a bunch of USB mouse. In that closet in the back over on the right hand side when you walk in the closet door. Whoops. And when you zoom in and out, control scroll, the standard zoom, it scrolls to where your mouse is. So if I'm out here, put my mouse here and scroll in, notice I'm zooming in below it, or zoom in up here. And that our graphic software will have the same thing. So that might as well mention it here. So it looks like we just need to load in an image. Right? Get this out of the way. Okay. And oh, too far. It takes a little bit of getting used to, but edit image, import an image. I'll probably do that. I believe the ones from last week. I bet I did. Documents delete. Yeah, I did, but I can go grab it from GitHub. Zoom thumbnails are very problematic today. Over in GitHub, I did set up a repository with the stuff from our class here. So Francis-Chris5 is my account on GitHub. And I made a repository SDEV 148-fall 2022. And you can go grab any of the stuff from here if you need it. Oh, not upload, download. Quick way on the green button, you just download a zip file. If you don't know how to work with your repositories and command prompts or anything. That'll show up somewhere along the path through school, but I think a lot of people are in like their second or third class. And probably haven't seen all that yet. So it downloads, if I extract this. Also, here's those walking animations from last week. So to be able to import those in right in here. Download this. Probably should have just went there in this file explorer. A few images, bring those in. And you'll see this message box a lot. Obviously, there's that checkbox at the bottom. I would highly recommend not checking that box and just hit yes every time, because when you hit those non-undoable actions, that seems like a strange word, the actions that can't be undone, you want to be careful with it. So a little preview, you can see our character walking, adjust the speed and stuff, change the size, you can click around, try different things. Let's say like 18 frames per second. Walking a little bit slower, but it looks like really quick to just load an image in. And now that we have an image, we should be able to create an object to put that image in. Create an object. And you'll see there's several different components here. If I zoom in so y'all can see, so one of the options in that first section is obviously for a sprite. So we can load in one of the sprites. Oh, I could have pointed at this. Notice after I created object, it added things to that folder, or it added a new folder down here. You want to highlight the folder. It's a lot better to click and create over here, because then it'll put all your stuff in the right place. And organization goes a long way. Like the object can also drag and drop and do all that stuff. Same thing, put the sprite in the sprites folder. Organization goes a long way, but right clicking over there works a little bit better. Right clicking in the middle seems like a good spot. And you see a lot of stuff here in the GUI. Collision masking, events, parent objects. We'll talk about some of that soon. But after those basic configurations are done, it moves over to the events. So we can do different events. We click add event, there's create. So what happens when it gets created? What happens when it gets deleted? When we're done with that object in the game? What happens? Some drawing stuff, mouse clicks and holds and hovers. I'll just use some key presses, so maybe keep digits or letters. I use the A key. What? Add event. Key pressed. Maybe I was on key down. I'll just use key pressed and choose the A key. Where is this up here? Nope, I should not be scripting that. Delete that. Are all of my things going to do that? Keeper. Letter A. Oh, and choose visual for our class here. There's a scripting language, but I chose this one for the GUI based version. So when you see this little menu, make sure you choose GML visual. And again, you probably don't leave those boxes unchecked. That way it asks every time. And you have control over it. And then when we do a key press, see these windows are starting to add up. Come over here, and then there's a lot of things that can happen. Some common features, as we scroll down, instances are for like creating and destroying the instance. Sequences, things from controllers, movement's probably a good one. So there's a little option to set a direction. So the A key would move us to the left. And there's different ways to do it. Variables, point in the direction. We also set speed, so we have some direction, maybe horizontal, and -3. So more than one way to move left. I can point to the left and then set speed. And it's kind of hard to see there, but you see how there's a little green line connecting those? So that's the sequence they're going to go in. So first thing, it would set direction, then set the speed. Yeah, I'll do 3. And relative is to what it was already. So if it was already moving, then that key press would make it move faster. Or just move at a different speed. So we set a direction and a speed, which will get our character moving, and then there's lots of these little things we can drag over for whatever we want to do. We could jump to the starting position. Delete that. We could draw some text on the screen. We want to click around and kind of get started looking into these things, just doing a very quick pass here. And you might have noticed that over here, this is like a file explorer. It's just suggested names for the folders. Obviously, you can rename those. Over on the right, I just realized it's not showing on the TV in the room there. So all the stuff over here, organization goes a long way, especially as your games get large quick. But right off the bat, one of our folders did not start empty. We started with this room here. You can open that up, and it's not really anything in the room. But when we opened it, that's where the inspector panel is. I guess I could also point at the object here when I click on the object. Something should have shown up in the inspector panel. I was expecting it to. Not showing up in the inspector panel, but over in the inspector, we get all the information about the room, the instances, what background is there. So we have a background from those things the other day, so we could load that in, but before we do that, we need to load in the sprite from the other day. So if you right click on the sprite folder and create a new sprite. So yes, I know this is going very, very quickly. Just point into some things and y'all can click on click around in it a little bit later. Oh, there it is. So create a new sprite, and once again import an image, and we have this background. So then once that's loaded in as a sprite, over in the workspace, organization goes a long way. So I'm going to drag the sprites up here together. That way the sprites are in one area. We can drag that stuff all over that big empty area. So keep in mind from the beginning, organization goes a long way. And then when we're in our room, we can go ahead and import that. Oh, well, the inspector's working like I was thinking now. So when that's highlighted, now it's not doing it. It'll be okay. Or in the room, we can just choose a sprite for the background of that room. Which is a different size picture, so might want to adjust it a little. But then the other thing is we need to put a character in there. Everything's clearly labeled. You'll find where to adjust sizes, X's and Y's and all that. and we have an object. So our objects are like our game pieces. Oh, now it's showing up in the inspector. I guess I have to click over and over here. Clicking on it in the workspace didn't work. But if you click on it over here and just drag it in. Sorry, going back to the room. You'll see that. So we can deal with the background or the instances on the room. So after you get the background set, switch that back to instances. That one might not be necessarily super intuitive. You get a warning message about it. But if you didn't know where to look, that warning message wouldn't be very helpful at all. Switch it to the instances, and then you can just drag your objects from over here and build up your game that way with an interface. And I would highly recommend just clicking around a little before you could get started in the tutorial. Try to make one of your own things. You should have some images and things you can reuse from the first section. Instead, before even opening those tutorial assets. And then when you're ready, obviously there's a run button over here. So I think that's enough to run the game. We load in our sprites, put an instance of it, put an instance of the sprite and inside of a scene with that background set on it. Hopefully that's sounding very familiar from what we looked at in Pygame, right? And all I did was the A key, but if I push A, we start going in the positive direction. Because we set speed positive. Negative speed might have been a better option there. So if we go back in the workspace and adjust this, maybe just direction, let's see if that works better. Oh, I didn't realize that was scrolling. Okay, now he goes in the, now he starts moving left. But it didn't stop when I released the key. So we probably need a key release event. And similar things to what we saw before. Start clicking around. We can see it's all based off these little pictures in a GUI. Makes it a lot easier to work with, a lot more intuitive. Give that a try. And we will look at a class example soon of that. Probably start about halfway through the day on Wednesday. Just want to look at some graphics. And this is a good place to look at. Seems like a good time to look at that. A very intuitive engine to work with next. And make sure, save your project. Okay, they got rid of the save file button. A project is made of lots of files. So if you haven't seen it yet in programming, our programs usually involve more than one file, and we'll have a save button and a save all button. You always want to make sure and save all of the files, not just the current one. Otherwise, you might not see every change. It looks like they got rid of that in the latest update, so make sure everything's saved in the project and just close out when you're done. Click around, give that a few tries, give a few things a try, see what you can figure out on your own. It's a very intuitive thing, and then that'll make the tutorials a lot easier to work with and a lot easier to customize and make your own game instead of just doing an exact duplicate of the tutorial. So we need to take a look at some graphic stuff today. I'm going to look at 2D stuff first. And then we'll go to 3D stuff. So I'm going to open Inkscape, and I'll just draw a quick picture. Actually, I'll just open that picture from last time. Because we saw how to draw that. Does everybody remember drawing that? With that pencil thing real quick, I was showing somebody the artist type pencil where you have, it's like traditionally drawn with a pencil and you have that special tablet that feels like paper. Feels like really good art paper. The stuff that's really heavy duty sketch paper. feels like you're drawing on there and a pencil. I was showing somebody that stuff the other day and pulled up a picture on Google. And one of the pictures was from a new one they put on Amazon for $28. Usually that stuff's like 50 or 60 at the low end. But Amazon had them load for $28, so I ordered that last weekend. It's supposed to be delivered today, but it wasn't delivered before I left the house. So on Wednesday, I might have that pencil to kind of show how those go, but give it a test. Hopefully it's not just an expensive piece of trash, but if it works good, $28 to get started on those. And with that pencil, you just kind of draw characters out, set colors. We saw that the other day and the video is recorded. It takes practice. Here's their icons for pencils. Like if you, this one that looks like a calligraphy pen, you can do nice smooth Bezier curves. Or really these first two options are the ones you want. So with the Bezier curve, you would define like 3 points and then it passes through all 3 of those. Finds the smooth curve that goes through all those points. You can also, the very first one just gives you straight lines. So if you click a bunch of points, you get straight lines, and when it closes up at the end, you have that solid shape there. Yeah, I guess I'll redraw it. Really, the only thing I was going to change was something about the legs. I'll just redraw it to kind of go over the steps again. So I'm going to go with the regular pencil instead of the straight line one. That might be easier to get started with. I'll just click and kind of drag my mouse around like a pencil and do a character profile. So there's like a character's head, give it some sort of skin looking color. Then I'll come back in again and click and draw a shirt or torso. Give it a green shirt. Maybe not that one. So Control Z to undo it if you're not happy with something. And really it's dragging your mouse around like a pencil there. Okay, that gives us a sort of a shirt. And what I did for the arms on the last character, I want to do for the legs this time as well. So remember that for the arm, just kind of came down here, same thing. I tried to estimate about where the bottom end of a t-shirt would be and just drew the rest of the arm after that and throw the color on it. And then all of our stuff is still separate pieces. We can still go back and edit each one because we're in vector graphics now. Oops. Click the little arrow, we can select them one at a time, grab them, move them around to wherever we need them. And obviously, if we can select them one at a time, we can hit Control C and Control V to make a copy of it. And then kind of put the left and right arms together. I'm going to go ahead and, with that one of them selected, go up to Object and lower it to the bottom. That won't really make a difference because this is 2D software. We don't have a third dimension. So when we move this into 3D software so that we can animate it, it's going to put them all at the same level again. So we'll have to adjust it later. But I'm going to do that extra step because it would seem weird to have both arms on one side on a regular person. If it was something that had 4 arms, then 2 on one side would be okay. And now I'm going to do some legs, but this time I'm going to do the same thing I did with the arms. I'm going to draw the legs. I'm just going to draw one leg. That'll work. And make it the color of blue jeans. Probably make that a little longer. I'm grab that and just stretch it down so that it looks more proportionally correct. So that's the first big advantage of vector graphics is everything is still independent. It's not a finished image. The computer is saving the image as a math equation. There's a whole bunch of math formulas so that any adjustments we need, the computer just automatically recalculates. And then both legs are basically going to be the same. So I'm going to select it and then do copy and paste. and just kind of put it right on top of it. That'll be fine for now. Actually, I'm gonna hit undo once. I'll copy and paste in a minute because we also need a shoe, which is gonna be an exact duplicate, right? Our left shoe usually matches the right shoe. Just like our legs, we want those to match. So I'll go ahead and grab the pencil and just kind of drag that around and draw a little shoe shape. Not super fancy, and maybe brown shoes. That's a good color. Move it into a good spot, something like that. And now I'll select both of them. Holding down Control and Inkscape, holding down Control will allow you to make multiple selections. I think Shift will also allow that. Let me try that. I hold Shift. Oh, both of them, either Control or Shift will both allow multiple selections. So just copy that, both of them, and paste that in. And then while they're still connected, drag them in place. So there's all the pieces of a character. Can't even see the other leg, but that'll be okay. We know it's there, right? If we open this up in the text file form, we'll be able to see the text file. So there's our 2D image. We can go save this somewhere. Probably make a folder to keep things organized. Graphics examples. That's going to go on GitHub, so I don't want to put a space in the name or in a camel case. And this is character 2D. And it's vector graphics, which in two dimensions, to the computer, they look exactly the same, but to a human, they would get overwhelming at times. I cut it off. So I could save the document properties. Right now, mine's set for a 512 by 512 image, but you want to try to make sure it's all inside of that white box. So I'm just going to grab, select everything and then scale it down with one of the corner drags. So, I guess it didn't really save the aspect ratio anyway. Scale it down so that it all fits inside that white box. There we go. Now we see the whole image. And the big thing is with vector graphics, they're kept in human readable form. So if I come over here and open this with my text editor, it is just a markup language. You'll probably notice my computer set so that it opens with the browser. Yours might be as well with SVG stuff. So there's all these markup tags, and the SVG tags will go right in HTML code. If you need to use that, SVG is part of the HTML 5.0 standard. But everything's saved separately there. So we have G for graphics, and then we have a whole bunch of different paths that we drew. So I'm guessing they went in order. So this is the first one here. We turn in word wrap. So the first one, we started here, and then there's a whole bunch of points afterwards. So we start here, and then we go over half a unit and down 9/100ths of a unit. And then we go over 3 units and down another 8/10ths of a unit. So the starting point can change, and then everything else is the vectors relative to that starting point. That's pretty much the standard for storing 2D graphics. 3D looks a little bit different in human readable form, but internally it's the same thing. We have our starting point, and then the vectors to point to every other important spot on there, so the image can be regenerated as we need it. So now, instead of like we did last week, where we did then we drew a couple more pictures or made copies of it and made slight adjustments to animate it. Let's have the computer do those animations, because those slight adjustments we made, the computer can easily handle it. And what we have to do will hopefully make a lot of sense, because it's a lot like what your body is, or what you are. I'll say it that way. I'm gonna stop my screen share for a minute. And when I'm standing up here, the standing is just kind of a big thing automatically, right? I'm not collapsing under the pull of gravity and being squished into a blob. Right? The human body can't handle that. We have that hard shell around our most important organs. Our brain and our cardiovascular system could not handle just being pulled completely down by gravity. So we have that solid structure inside. Severe burn victims are an example. You couldn't live well, but you could live without skin. Not comfortably, right? Like that, live without skin would be like a severe burn victim laying in the hospital bed. You're not going to die while your skin grows back, but you could not live without a skeleton. So in a lot of ways, you are a skeleton and you just have a skin surrounding. So in order to make an animation from one image, we have to do the same thing. That image is the skin. It can't do anything, right? If it wasn't for my skeleton, I would just collapse into a big puddle of biological material. So we have to give it a skeleton, and then this, just like our real bodies, the skin follows where we position the skeleton. So we'll do the same thing in the computer. And we can do that in Blender, which is probably one of the most popular ways to do 3D modeling. So we do our 2D animations there. 3D handles lots of stuff. It's open source, so free to use, free to add stuff to. If you want to extend it more, it's entirely coded in Python. So if you have an idea, you just code it up in Python and add it to your version, send it off to the Blender Foundation. If they like your idea, they'll add it to a future release. It's really, really fun to do that stuff, but it's grown into something really large. It's also expensive paid for software, which probably doesn't sound good as from a student perspective. But keep in mind, when you're out there making really good software developer money, come tax season, the IRS is going to want a huge chunk of it. So you want to have itemized deductions, and the expensive graphic software for a game developer would be a business expense. So it's an automatic itemized deduction on your taxes. So that's where the big paid for stuff comes in. A lot of them probably use Blender, but they have Autodesk Maya that they claim is what they use for their game, because then they get a tax deduction. So we're going to use this software Blender. Immensely popular. Tons of a huge community has grown up since the 1990s around this software. So lots and lots of tutorials, support, all sorts of things to help get you started. But it's huge, so it's really, really hard to find the beginner tutorials. So we'll walk through the first couple steps so that you know what to do and you can start making sense of the tutorials that are easy to find. So when you open Blender, you'll see the screen looks like this. And guys, real quick, I'll go ahead and throw this note in. I was going to mention it at least twice, because most of y'all are software developers. This huge, powerful software, or it at least gives the illusion of being huge, powerful software. If we tried to do everything that Blender could do, if we tried to load that all into RAM, it would take an incredibly powerful computer by today's standards. And Blender's been around since the 1990s. The most powerful computers we could buy today would probably start slowing down if we loaded in everything that Blender could do. So when you see that new screen, hit next and probably choose general every time. Just start with a general one. I know there's a 2D animation one there, but just go to the basic one. And you'll see there's buttons everywhere. You probably want a regular mouse. If you're on the touchpad on a laptop, you can come up here and kind of grab that. Otherwise, I guess just for navigating, if you hold down the mouse wheel, it spins around. If you hold down shift and click the mouse wheel, the middle button, then you get your panning. So there's going to be a lot of positioning things and adjusting that. Different types of ways to select things. I guess let's start there. So it's this button right here, but that's when you're going to want to probably switch to your preferred selection type every time. So to select things, by default, it's going to try to select in a box. So you can draw a box around there. And notice it included a camera and a cube and a light source. So we need that. Light source will make a big deal when we get to the 3D stuff. Colors aren't enough. That's the biggest change from 2D to 3D, is that in 3D, a color is not enough. In 2D graphics, we can just say what color we want. But in 3D, we have to actually say what type of material it is. And color is just part of the material. Right? We can't say, is it green? We need, is it green metallic with a rough surface, really smooth surface? Polished, is it highly polished, or is it really rough? Is it metal? Is it plastic? Because the type of material makes a difference in the color. So we'll see some of that stuff. There's quite a bit going on, just introducing it. So to select stuff, if you push the W key, it will switch this top button here that shows how we select it. And this like selects by a circle. So if you click and drag, or anything inside that circle can be selected, which is kind of small to begin with. And the third time is the one I like. That's the, you see sort of a weird shape in that top button there. Push W again, and then that goes to the freeform selection. So you just draw whatever shape and just surround everything you want to select. And we'll put all that stuff back in. So I'm going to delete that stuff. So that way we have a nice empty spot. And usually what we'll do is we'll go to the add button and add a mesh and just put in a cube. We just deleted the cube, and then a cube, we'll get to this later. I'm just previewing this before we look at the 3D stuff. A cube is actually these 8 dots floating in space, and then the connections between them. So we can just grab those and move those around in space. So we grab that dot, drag it over and up, or this one. Just keep dragging those vertexes around in space until we find the shape we want. We're going to look at that soon, but first off, I want to do the 2D stuff. So I'm going to switch back. Notice right below the main menus, just edit. We'll switch back to object mode. In object mode, we deal with the entire thing at once. And in edit mode, we deal with them one at a time. And you'll notice there's a lot of buttons on here. This is not even all of the functionality available. This is the recommended functionality. I'll do it down here in the play section. So I could change all of this, and here's all of the different options of what can show on each panel on the screen. Categories. And then there's more options under that. There's a lot of stuff. So it would bog down software. But there's this nice little trick that never shows up in a classroom because it takes forever. And that's that we don't have a huge, massive piece of software here. What we have is a GUI and a database. But unlike the databases you're probably immediately thinking of, where we put in a bunch of numbers and words and our data points, the database is filled with instructions. So we can store computer instructions, computer code in a database. And then this GUI, all of these buttons, all they actually do is run queries on that database. So up here, if I come way over to this tab that says scripting, it's all scripted in Python. There's some different sections here. We can customize all this. See, there's a Python terminal. And then this section down here is the big one. I can still see the layout. So if I go to add a mesh and a cube, like we did just a second ago, you'll notice something happened down in this little right-hand corner. And all that button does is create a query that goes over to the database and grabs the Python instruction that brings that back and running. So it looks like huge, massive software, and it runs really, really fast because there's not really anything in RAM. The GUI's in RAM, and then the GUI creates queries, but all of the instructions for what the buttons actually do are still over in storage. And they grab one at a time. So all we ever have in RAM and the CPU at any given point in time is the GUI and the current instruction. A really useful trick. So all of the code for the software goes in the database and various database tables, usually relational database tables, because we know exactly what that is without a bunch of empty spots. And then we can make software that appears really, really huge, but it's just the illusion of being huge. All we're ever having at any point is the buttons on the screen and the instruction for the button we just clicked. I'm going to copy that instruction over here in a new Python file. I'll paste that in. So we can also just type the Python instructions if you know those. And get a lot of stuff done that way. Quick introduction to how powerful this is. So like there's the instruction to type a cube. So it called this method, and obviously if you're typing it by hand, you don't necessarily need to type every single detail like they have there. If we type it by hand, we could just say from that module. So we do have to import BPY every time. I'll say it out loud. Import the Blender Python module, because that's the one that has all the code we'll need. And then from that module, we have this ops object, which has a mesh object. And one of the methods in that mesh object is a primitive cube add. We could probably skip that if we needed it. Skip that parameter if we were typing it by hand. So all we really need to know is location and scale. Our transform data. Where are we putting it and how is it scaled? There's also rotation stuff, but we'll get to that later. So that capability is there. We'll look at some more of this stuff later. Scripting tab. Shading is where we set up materials, find what all things are going to be. UV editing, we can get highly detailed images. Notice how over on the left-hand side, it's like it unwrapped that cube, so we can see each face of it. We can take that and export that over to a really nice graphic software or Microsoft Paint. And then we could draw a picture using those as references. So when we import that picture, we know exactly how that highly detailed picture will wrap around that cube. And then set really nice graphics up that way. Everything's made for it. Sculpting is very nice. We'll see this soon. Actually, I have to do one thing. Let me go back in layout mode. So I go in edit mode. And right now there's these 8 vertexes floating in space. Move that around, but there's still only 8 corners to the shape. If I push, I'll right click instead of the keyboard shortcut, I'll right click because that's probably the go-to anyway. And it subdivide, it starts splitting that up and we get more shapes on it. So I'll just hit that a few times. There we go. So now I have to zoom in, but you can see there's lots and lots and lots of those little vertexes floating in space making up this shape. So we can get a lot more detailed shape on that, which will make more sense when we see that soon. I just need to do that for previewing this. So there's also this tab that says sculpting and different ways to get to these tools, but we have basically like chisels working with clay. So we can just take and add a bunch of little blobs here to get some more stuff to work with. And then come in and treat it like a chisel. So I can inflate a little spot here. Like add in a little more clay, or in the red ones, smooth it out, flatten it, fill it in, scrape little lines in it and stuff. And you can make your model like you're molding clay. Find one of the little chisel shapes and start, instead of grabbing an individual vertex and dragging it around, you have like the chisels to work with clay. So the blue ones add clay, the red ones adjust the clay in holes, so like smooth out an area, scrape it flat, all that stuff. And then you have your traditional chisel shapes down here, so you can just grab stuff and like twist the clay, or it's like I'm twisting it again, and make really detailed models that things look realistic by adjusting that clay. There's more stuff. Since it's almost break time, I'm going to go ahead and show one more thing here. So if I come over to the edit menu and preferences, under add-ons, not even all of the buttons are turned on. So you're probably already getting overwhelmed by how many buttons are on the screen. And look how far I have to scroll. Look at how long this list is and how few of those have check marks beside them. So this is barely scratching the surface. Let me put in tree. And it's vector graphics. Oh, sample. Oh, tree. So being a tree, that means everything is handled as being vector graphics means it's all handled as equations. And we can describe a lot of things in equations. That video I pulled up earlier, I will put the link in the chat room here in just a moment. He uses a lot of these things. But now that I've turned that on, under my add button, I should have another option under mesh. I have to restart preferences. It's add. Oh, install. I'll say go ahead and install that add-on I selected. Hopefully I don't have to restart. And go to add. And under curve, there's now this option for sapling tree generator. So instead of a cube, I added a tree and can do all sorts of different things here. So other presets. So instead of like a cylindrical, maybe I wanted one of the more spherical trees. Change that to conical so the limbs point upward, and increase the branch distribution, and add a bunch more branches, sort of a different randomizer, and notice that it's just all of the parameters to define making a tree, instead of sitting there moving those vertexes around out in space all at once. So obviously, if we can do one tree, we can do a whole forest. That's what was in that video earlier. Where's leaves? Oh, there's presets. Or if you knew explicitly you wanted a pine tree, or a big aspen tree, or willow tree. Oh, willow tree kind of crashed. A maple tree. Oh, willow crashed for some reason. Then I could add leaves to it. So let's add a whole bunch of leaves. Why am I not seeing the leaves on there? There we go. And you can see we add leaves to the tree and it's all equations, so we can just take advantage of the software and do a lot of the stuff that way. Generate entire forest. That's probably not a starting point. I just wanted to show you it was capable and we had a moment there. That's what was going on in that video I pulled up earlier. Control H. That camera. So there's the link to that video if you want to check that out later. Copy and paste and save that to look at it later. To start with though, we want to do a 2D animation. We drew one picture, one 2D picture, and we want to animate that without drawing 50 different pictures. So we'll look at that, but it's probably a good time for a break first. But Blender is big, powerful software. There's a lot going on here. One more quick preview button. Since I already mentioned it a couple times today, let me add a cube back in. If I extend this, notice when the cube is selected, the primary data again is the transform data. The location, rotation, and scale. We have that everywhere, so you want to get used to that and notice and working with that. Now, how do I get that out of my way? Oh, put it like that. Which we can also get to from the yellow button here. This menu over here is where you'll do most of the work. So the yellow box is the transform data. That's very important. But we're going to start with a 2D image. It's probably a good time for a break. Does 10 minutes sound good to everybody? I see head nods here in the classroom. I'll use this clock. 2:09, so we'll get back to it at 2:19 and then animate that one image we drew a few minutes ago.